Okay. I see that there was a question online.
It's not a question, it's more of a request. If everyone would check and make sure that they're muted, that would be greatly appreciated.
Yeah, so we don't get echo, I guess, in the recording. And then the other question that I saw had to do with where's the sign-in information online. Sorry about that. There is no sign-in information if you're online. You guys, so in the announcement it says that the people who attend the class get virtual machines. If you, there's like 100 sign-ups online, so we can't get virtual machines to like 100 people easily. So you guys are going to have to, if you want to follow along, you guys are going to have to obtain your own, preferably Ubuntu virtual machines. So hopefully you're able to do that. Okay. So before I begin, let me ask a little bit from everybody. How many of you, like if I talk about, let's back up. How many of you use Linux on a pretty regular basis? That's what I'm talking about. That's great. Okay. How many of you, if I talk about Linux containers, you know what I mean? Okay. All right. How many of you are using Linux containers already? Just like a few. And then final question, how many of you are using Singularity already? It's like one person. Okay. All right, cool. So hopefully everybody who's not using Singularity containers already, hopefully we'll get a ton out of this class, and hopefully even if you are using them, you'll get a lot out of the class too. All right, cool. Thank you. I guess I'll introduce myself a little bit too while I'm at it, while I'm laying groundwork. I'm David Godlove. So I used to be here at the NIH. Actually, a long time ago, I was here at the NIH as a postdoc working in the NIMH. I became more interested in kind of like computing and high-performance computing and things of that nature, and I ended up joining the BioWolf team. I was there for a couple of years during the period of time during which Singularity was being developed by Greg Kurtzer out in California. And so I kind of worked with him a little bit, helping to develop Singularity. And then when he spun up Sylabs, which is the company responsible for Singularity at this point in time, I joined him there and worked there for 2 years. And now I'm just kind of returning back to the NIH again. And so that's kind of like my experience with high-performance computing, NIH, and also with Singularity as well. So that's kind of my little introduction. Okay, and I want to, we're going to be following kind of not really a script, but like a pre-laid out class, and I want to show you where that's at. So if you could open up a browser, and it's going to be important for you to do this, because if you get lost or something, so it's going to be important for a couple of reasons. Number one, to start off with, we're going to be installing Singularity. Sorry. So to start off with, we're going to be installing Singularity, and we're going to be doing that from scratch. And there's going to be like wget commands that have URLs and stuff like that, stuff that you're not going to want to type out. You're not going to probably be able to type out in a short period of time. So you just going to want to copy and paste this. This is very similar to how you would install Singularity anyway, because you would copy and paste commands from the Singularity documentation if you were going to install Singularity. So this is going to set you up kind of, to do things in the right way. And then second, if you fall behind, as I'm doing stuff, this is going to get you back up to speed, right? You definitely, if you do fall behind, holler at me. I'll stop and I'll slow down, but this is going to help you also kind of stay on track as well. I don't want to lose you through this. Since everything's building, we're on top of the next. If you go to this repo on this introduction README page, you're going to find all kinds of links. And, you're going to want to maybe email this to yourself or save it in the Slack or do something like that, because all these links are going to be helpful to you as you continue to learn about Singularity. I think first one should be the Singularity documentation. Yeah, no, it's not. Sorry. But if you go up here and you hover over Docs, then you'll see there's user guides for all the different versions of Singularity. I'm going to cover on the basics of Singularity, but as you learn more about it, you're going to want to become familiar with this documentation. Okay, there's also links to Singularity on GitHub. Google Group, this is a good place. The Singularity community is a really welcoming, good community. And so the Google Group is a good place to go to ask, beginner questions. They're very helpful. There's also Singularity Slack. There's Slack for everything these days. NIH HPC has got some pretty decent documentation. Also, it's got like specific tips for using Singularity on the Beowulf cluster. I've got some links to Docker documentation too. I'm not really going to be talking about Docker too much except as it relates to Singularity in this class. And then I've got a link to the Singularity Container Services. We're going to be talking about that a little bit more on day 2. That is a remote builder, which is a place up in the cloud to build Singularity containers, a library to store and download other Singularity containers, and a key store so that you can sign and then verify containers. We're going to be talking about that a little bit more tomorrow. And then I've got a link to Docker Hub too. Docker Hub, kind of like GitHub, is another place that you can store containers. Those are in Docker's format, but you can still use those with Singularity. All right, so let's back up. So what is a container? So a container, it's kind of analogous to a virtual machine. So, if you already have a good understanding of what a virtual machine is, you're already well on your way to understanding what a container is. A container is an encapsulation of an entire root file system along with an application. And it allows you to take an application or a group of applications and package them up in a nice, neat little box along with all their dependencies, their environment, and everything, and then save that as one unitary thing. And then you can take that and you can move that from one computer to another, to another, to another, and it's going to work the same way, regardless of what computer that you run it on. So it helps for things like reproducibility. It helps just for ease of use. It's much easier a lot of times to install things using a package manager from a Linux distribution than it is to install things from source. And so a container lets you do that. It lets you spin up a new container, use the package manager as root, who cares, it's going in the container somewhere, and then just install it easily and then move it to wherever it is that whatever place where you're not root, and then, go ahead and run that application there. So here are some of the things that you can do with it. I've already, kind of talked about a few of those. Containers are really big in the world of pipelines. So people who write, different pipelines to analyze data, a lot of those folks use containers in order to orchestrate all that. You could do things like you could publish a paper, and maybe you could take all the data and all the analysis that went into the paper to create the figures, and put all that into a container and package it in such a way that somebody else who reads your paper could have a container, press play, and then all your figures would pop up, and they could go into the container and play around and look at it and see how all your analysis worked to do that. Like I said, you could install an application that has a complicated software stack, and you could do so much more easily. And you can also run things that require a specific operating system. Actually, at Beowulf, when we first started using Singularity, that was one of the major use cases for Singularities. At the time, we were running RHEL 6, and everybody got really excited about TensorFlow. Well, guess what? TensorFlow wouldn't run on RHEL 6. And so for a while there, basically everybody who was running TensorFlow, which was a lot of people on Beowulf, were all running it in Singularity containers because you just dump Ubuntu inside of a Singularity container and then TensorFlow on top of that. Problem solved. So containers are good for lots of different things. Now, I said already that they're kind of like virtual machines, but how are they not like virtual machines? What's the difference between the two? Well, so you can think of your computer as like a stack, right? And at the very bottom of the stack is just hardware. That's where your processor and your memory and all that kind of stuff sits. And then on top of that, there's a kernel. And that kernel is the thing that has to operate the hardware. And then on top of that kernel, you've got an operating system. And then on top of that, you've got a file system. And on top of the file system, you've got applications that are running. So that's basically the stack from the hardware all the way up. If you install a virtual machine, then on top of that, on top of the file system, you got another kernel. And you've got like this virtualization, which makes that kernel, work. And then on top of that, it's got, the operating system, the file system, and then, applications are on top of that. And so it's a lot of layers of indirection. What a container does is it shares the underlying kernel. So it doesn't replicate that kernel. It just takes the existing kernel that's already there and basically just plops in their file system on top of it. And that's pretty much all a container is. And what that means is, in practice, if you're running a virtual machine, it's going to take a long time to start. It's going to be resource intensive. It's going to use a lot of your computer's resources just to run itself, let alone run any other applications. But with a container, you're leveraging all the kernel that's already there, and you're just running a different file system on top of that. And there's a little tiny, we're talking millisecond or less startup, in the milliseconds or less startup, associated with creating that new container. And then after you do that, the applications inside run at native speed. They run just as fast as any other applications on your system. With some assumptions, assuming that you don't have like an old library inside your container which is slowing things down or whatever, but they run just as fast as your applications would run if that same operating system with those same libraries and everything were installed on bare metal. So that's really the difference between a VM and a container. So it sounds like containers are better, right? Well, yes and no. They're better for certain things and they're worse for other things. Like, so say you wanted to run a Windows application on top of your Mac. You're not going to be able to do that with containers. Containers are pretty much Linux only, and that's because they rely on some specific features in the Linux kernel. Okay, maybe I want to run, a Linux container on a Windows machine. Not really going to be able to do that either, because once again, we're going to share the same kernel in the container as the operating system. You might say, well, I've played around a little bit with Docker, and I can do that with Docker. Yeah, you're not really doing that with Docker. What you're really doing with Docker is you're spinning up a little virtual machine, a little small Linux virtual machine, and then it's got Docker installed in it, and then you're running your container on top of that. Singularity will run on Mac, but it does the same thing. It just spins up a little virtual machine and does that. So virtual machines are slower, more resource intensive, but they're a lot more flexible. They're better for things like if you want to run an entire desktop, you want graphical user interface, GUI applications, you want to check Outlook on your Mac or something like that. A VM's probably a better choice for that. Whereas a container is a better choice for if you just want maybe you want to install, I don't know, Git or something like that. It would be quick and easy to do that in a container. Okay, so that's kind of like the difference between containers and virtual machines. Hopefully I hit everything that was here in this text. Okay. Then I'm going to talk a little bit about Docker and then also Singularity. Do we have any questions at this point in time? Yeah, so I'm going to repeat it because there's folks who might not have heard that. So the question is about like if containers are right, or if there's a workflow for essentially writing some software and then distributing it to other members of your lab so that they can then easily run that software within the container. So yeah, that's a really great use case actually for containers. Now you said PC in that question. That's not going to work with a PC, right? So if you're going to but it will work if you have a virtual machine on your PC running Linux. You write all your software there, package it up, and then let them run it within the Linux environment. It doesn't even have to be the same Linux environment. You can write it all on Debian, and they can run it all on CentOS.
And in theory, upload everything to Viable and that same type there when the work gets too big.
Yeah, that's a great point, Andy. So not only is it good for distributing out to the other folks in your lab, but it's good for writing code on your laptop and then running that on Cluster and then taking that over to AWS and running the same thing, or GCP or whatever. Yeah, and containers are really Linux beasts, and that's because so there's a pretty famous person in the world of containers named Liz Rice. And for a while, she was giving this talk where she would get up and she would, in the programming language Go, she would just start writing, and she would show you how to create a container in 50 lines of Go. And the reason why it's so easy to create a container runtime is because you're not really writing anything new with a container runtime. You're just exposing, in a certain way, some features which belong to the Linux kernel. And those features are namespaces. This is why it's a Linux-only kind of thing, because all you're doing is you're taking a collection of all these different, they're called namespaces, that wall off certain attributes of processes from the underlying operating system, and you're putting them all together into one easy-to-use package that users can take all those namespaces and spin up containers. That's really what a container is. So it really is a Linux-only kind of thing, not Unix, not Mac, not Windows, Linux. Okay. All right. Any more questions before I move it? Yeah. Good question. So the question, once again, I'm going to. So the question is, okay, container shares the same kernel as the underlying host. Does it share the same OS? And that's where things get a little bit tricky. So when you're talking about OS on Linux, what you're really talking about is something called the glibc. That's the C libraries, which allow programs to interact with the kernel. And you bring that with you in the container. So the container has its own glibc. Then it's got on top of that its own, user space and all of that, and it's got its own, programs and everything. So it's a different operating system in that sense. Things get a little muddy. We're not going to talk about it too much during this course, but with Singularity, and I'll kind of try to point it out when it's appropriate, you can add a flag called --NV, and that allows you to use GPUs on the underlying host system, transparently. And things get a little dicey with things like that because the way that a GPU driver works is it installs a module into the kernel. And then it installs a bunch of specific libraries in the operating system that are supposed to interact with that module that's running in the kernel. So unless you've got libraries that match directly with that kernel module, it's not going to work properly. And so that's where things get, some things should be very tightly matched to the kernel, and that's where things get a little muddy.
We have a request. Can you tell us more about the security concerns that we should be aware of while using it?
Absolutely. And on day 2, I'm actually gonna spend, well, actually, it's towards the end of this day, and I think into day 2 as well, I'm going to spend a significant amount of time talking about this. So I don't want to jump into that right off the bat because that'll get us kind of derailed. But yeah, that's definitely a big part of this course. That's a great question, and that's the next thing I'm going to talk about. So let me just launch into it. Segue. Thank you. All right. Okay, so
one other quick question that you can push for later or not, but onto the stack. Singularity on AWS. Can it be done?
Yeah, definitely. So AWS, I don't know. Okay, so AWS and Sylabs works together. I don't know, like, the companies. I don't know, that's really not the question, though. But like, AWS supports Singularity containers. I don't know how deep their level of support is right now. I think that containers are better supported right now on Azure. But like all three of the major clouds, like host Singularity containers, are aware of Singularity containers, and are kind of working to some extent or other with Singularity. Now, that said, you don't actually need the support of the cloud to run containers on the cloud, right? All you need is a Linux system. So if you can spin up Linux in the cloud, then you can install Singularity and run your containers there. But you can also get niceties like pre-built containers that you can start up. And I'm not going to be covering that in this course. I don't really. That's not my. That won't be my focus here, though. Although the virtual machines we're running right now are running on GCP, so clearly Singularity does work with the cloud. Okay, let's talk about Docker. So Docker is kind of like the Beatles of containers. The Beatles didn't invent rock and roll; they just made it popular. I could have that wrong, I don't know. But Docker didn't invent containers, but they just made it popular. Right? So Docker has been around for a little while now. It's definitely the most widely used container software. And the kind of folks that really use Docker a lot are like DevOps folks who are building like a bunch of buzzwords, cloud native, microservices up in the cloud. Like that's really what Docker is all about. That's its bread and butter. So what that model is I work on a team of software developers. We are building, I don't know, some kind of like a point of sale payment kind of system or whatever from scratch. So we are going to build it to run on AWS. So we're going to spin up a bunch of AWS VMs. We're going to, like every little thing, every little part of the system is going to be a little what's called microservice, which runs inside of its own little container. And that way everything is going to be very, very, everything's going to run just by itself, kind of. And then we're going to orchestrate all that with Kubernetes running underneath the Docker. And the reason why one of the reasons why Docker's going to be great for that is because it's going to, so Docker containers come in layers. What that means is, like, I might have 20 different microservices all running on this one VM, but they all have the same base Ubuntu operating system. And so because of that, they can all share the same base Ubuntu layer from their container. And they don't have to, that's deduplication of data. They don't have to all, have their own Ubuntu. And they can share on top of that, maybe half of them have Nginx installed. They can share that next layer that's got Nginx. And so because of that, I can have this one little VM, which, just has a few little layers of containers on it. And that's running all these different containers. And then I'm orchestrating those through something called Kubernetes. Kubernetes is doing things like handling load balancing for me. So if, I've got 10 different VMs all set up, all running these microservices, if one of them starts to get hit too hard, Kubernetes is going to say, hey, let's spread the load out over here. It's going to handle, if one of my VMs dies, it's going to say, okay, let me spin up a new VM, put these container images back on it, and do all that. So that's where Docker is really used a lot, and that's kind of like what it shines for. Now, in that world, it's basically assumed that you're going to be root on your virtual machine. Why wouldn't you be root on your virtual machine, right? Even if your virtual machines get hacked, a lot of times that's not really that big of a deal. You might just throw them away and spin up a new one, and put something in place so it doesn't get hacked again. And so that whole side of it is like the security side of it. It's you come from a very different worldview. You're not on a multi-tenant system. If you are on a multi-tenant system, everybody's trusted, everybody's got root access if they want it, so everything's cool. And that's So that's kind of like, you know, where Docker's coming from. Docker, because of its massive popularity, they've put out this thing called Docker Hub. And Docker Hub is a place where people build their containers. There's over 100,000 containers that are pre-built that are already up on Docker Hub. And that's, you know, so that's an awesome thing about Docker. Okay. Go ahead and grab a handout and sign in there. The handouts have IP addresses on them. You're going to need that to log in. So one cool thing about Docker Hub is that Singularity can grab Docker containers and ingest them and convert them to Singularity containers and use them. So all those like 100,000 containers that already exist up on Docker Hub, those are all like free to grab for Singularity users as well, and they can be used for Singularity. So Singularity, oh, yep. Nope. Well, it is. But you got to go through some kind of like backflips to get to. So I talked about Docker containers being like all these layers. And you'll see that when you download a Docker container, it'll be like, you know, you'll see all these little bars going at once, and there's like 5 different layers all downloading at the same time. What those really are is those are tarballs that come down, and then those are splatted out to disk, and they are put together with using an overlay file system, one on top of the other, in such a way that if 2 tarballs contain the same file, the second one will either like overwrite the first one, or it might have a file that says, hey, delete that file. And so they just lay one on top of the other until they create the final image of them. So there's a difference between the image in Docker speak versus the container. And the image is the thing that actually sits on disk, and the container is actually the thing that gets like stitched together and run at runtime. That's different from Singularity. Singularity is just a single file. And so when you grab a Docker image in Singularity, you take all those tarballs and you splat them out, and you the overlay file system to mush them together, and then you create a new file out of that, so you lose information. There's no way you can take that and then go back to the Docker file because you've just lost, you know, some information. So Singularity is a little different in that a single file is your container. So you can download a Singularity container, you can look at it on your disk, you know, it's there, you can look at its permissions and all that kind of stuff, and it's just file. And you could copy it from one system to another with SCP, or, you know, just drag and drop, or email it to somebody, or, you know, whatever. It doesn't come with a manifest that tells you how to take all these pieces and put them together into a coherent container. It's just, it's a lot simpler from that perspective. And because of that, that opens up a lot of different things that we're going to be talking about. And some things we won't be talking about. So some of the things that you can do with Singularity, we won't be talking about this, but you can encrypt a container with Singularity, and then you can, it'll be encrypted sitting on the disk, it'll be encrypted in transit, and it'll even be encrypted when you run it. And that's possible because you've got this like single image file, which can just be encrypted and be mounted onto your file system through a loop device in an encrypted manner. We're going to be talking a little bit about signing and verifying containers. That's another thing that the single file system lets you do. The other thing that's kind of different about Singularity is that Singularity was developed with HPC, high performance computing, in mind. So the story of Singularity is, let's see, about, I guess, 4 years ago, something like that. A lot of us in HPC were getting the same request from users. And that request was, can you install Docker on your system? And we went and we had a look at Docker, and we said, it's not feasible to install Docker on the system because then we have to make you part of the Docker group. And then if you're part of the Docker group, then you are implicitly root. And, you know, we're not going to make thousands of users root on the system anytime soon. So that's just not going to work. Most of us just said, okay, we can't do that, and we moved on. Greg Kurtzer, working at Lawrence Berkeley National Labs, he did something a little different. He actually said, well, what is it that you actually want out of containers? And he got, you know, users to tell him. And so then he went and he put together a proof of concept, and he came back and he said, does this do all the things that you want to do with containers? And that was Singularity 1.0. And his users came back and said, no, that's terrible. It's not anything like bullet one. But then they pitched in. So Greg is really, really great at building the community. And so he was like, can you help me? And he built this community, and all these users pitched in, and before long we had Singularity 2.0, which did a lot of the stuff that users wanted out of HPC. Singularity's got a different security model. So the whole idea behind Singularity is if you're not root on the system, you can't be root inside the container. And it's pretty much as simple as that. And then we will use the existing security, which is there in the Linux kernel, to provide the same security within the container. And so that's pretty much the security model of Singularity, is that you're the same user inside the container as you are outside the container. Greg called it Singularity because that single file container image that I was talking about. So he actually worked on a project. So Greg's a funny guy. He was one of the inventors of CentOS, the operating system, and he worked on a project towards the beginning of his career that ended up creating bootable USBs. So he was part of the project that ended up enabling you'd be able to plug a USB into your system and then boot an operating system. When he was working on that, they had an image file and they called it like code word the Singularity. And so he took that and said, okay, well that's going to be the name of this because it's this single image file format.
Question from are Singularity containers similar to Condon environments?
Yeah, they kind of are. So on the scale of like virtualization, there would be like VMs on one end and maybe Singularity containers in the middle, or Linux containers in the middle, and then Condon environments would be on the opposite end from the VMs. I don't think Condon environments have their own glibc, so they're not providing any part of the operating system, but they are providing, I guess their own like Python environments.
Or provide some libraries or require different versions or different versions of Python modules.
Yeah, so they're virtualization as well. They're in the same family, but I would say they're like a little lighter than Singularity containers. Okay, so I've kind of gone through most of the stuff here on Singularity containers, its strengths, its weaknesses. So whereas Docker containers really shine for, DevOps developers who are creating microservices and running cloud-native things, Singularity containers really shine more for scientific software running in HPC environments. And that's basically the takeaway. Okay, so So now I think what I'd like to do is get our hands dirty, get into the terminal, install Singularity, and then after we get Singularity installed, we'll take a break because inevitably that's going to be, something where a lot of people kind of get, this way and that way. We'll make sure everybody's back on course, and then we'll get back together and we'll start playing with Singularity. All right. Is this text big enough for the people in the back of the class? Oh, okay. Is it insane? Should I make it smaller? No, okay. All right, cool. Okay, so once again, I'm going to be kind of flipping back and forth because I'm going to be copying and pasting things from here, and I want you to do the same thing. And I'm just going to be explaining the commands as we go. We're going to go to 00, installing Singularity. And this GitHub repo, I'm going to be updating it as I teach new classes. That's going to be probably about once every 6 months. This is not going to be, so Singularity's release cycle is faster than that. So this is not going to be the most up-to-date information on how to install Singularity. For that, you're really going to want to go to those Sylabs docs that I showed you earlier. And you're going to see there's a lot of similarities between those documents and these documents. I wrote a lot of those that documentation too. But that documentation is quicker and easier because it's like 5 commands in a row that you just copy and paste all in one shot. This one I'm going to be going easy and kind of talking about everything. Okay. If you look at your virtual machine, let me or to the top of the screen a little bit more. If you look at your virtual machine, see that you're running Ubuntu 18.04. That means that the package manager, holler at me if I say anything where you're like, I don't know what you're talking about. I need to slow down. That means that the package manager, so in Linux, a package manager lets you install things really quickly and easily. They are in the upstream, in the mirrors. If they are in the place on the internet where the operating system. We're going to use apt. And I think the first thing we're going to do is, we're going to apt update. Once again, we're going to do that as root because you're going to update the system doing this. In order to update the system, you have to have elevated privileges. Okay. Once again, if I go too fast through this, if you lose the command that I just entered, make sure you got that web page up and you can follow along there. The next thing you're going to do is you're going to install a bunch of dependencies. If you've not updated, then your computer might not have like the location of the latest mirrors or something. So if you don't update, you might have trouble with this next step. Okay, this is a whole pile of dependencies. Sorry about that. Singularity used to be so simple, but it's gotten a little bit more complicated in recent years as we've added more features. So just copy and paste that whole thing. If you are on PowerShell, I believe a double click will paste. I don't think you can do like the Control-C, Control-V combo. If you run into trouble with any of this, raise your hand, holler. There's 3 of us. We'll get you back. While that's installing, I guess I could go through some of this stuff. So the package build essential, package build essential is going to give you and the program make and all the stuff that you need to actually build software. Then these are some libraries. So we got SSL, UID. So these are mostly libraries that Singularity is written against. Squash FS tools, the file system that Singularity runs in is a squash file system. It's a compressed file system. So when we start downloading containers and looking at them, they're just single files. Within that file lives an image, which is a file system, which is a squash FS, squash file system. SecComp is used for some security features we're not going to really get into. wget is the program for downloading stuff. We're going to definitely use that. This is another Git, obviously. Crypt setup. I'm not going to explain that right now. And DE Bootstrap is a program we're going to use a little bit later on. Basically, what DE Bootstrap does is it builds a Debian file system. So this is a way to build. It's one of many ways to build a container. All right, we're good to go now. If you happen to be on CentOS, which none of you are, hopefully because you're using the machines that I've given you, but if you did happen to be there, you would use Yum. That would be your package manager, and you would basically be installing the same stuff, but it would be named all. Okay, so the next thing we're going to do is we're going to install Go. Singularity is written in the Go language, which is published by Google. To install Go, pretty simple. You download an archive, you extract that archive to somewhere which is on your path. In this case, we're going to be extracting it to user local, which is on your path. And then we're going to make sure, then we're going to make sure it's on your path because it's going to extract the user local Go bin. let's go ahead and do that. This wget is going to download this archive, this tar.gz, from Google. In there appropriately. Yeah, and please holler once again if you're having trouble with this procedure. To make sure that you get this, because if you don't have Singularity on your VM, not going to be able to do much for the rest of it. The next thing we're going to do is we're going to extract that archive. I'm going to break this down. So, use the program tar, stands for tape archive because old stuff, to extract the archive. I'm going to tell it to extract the directory user local. That's owned by root, and you can't write to it. You got to be sudo. And then xzbf, this is just a way to tell tar what kind of archive it's dealing with. The D means verbose, the F means from file, the XZ means, just tar. Tar is smart enough that it's able to pretty much figure out what the archive is, but it still needs these letters. And all that's going to do is extract the archive. I'm going to leave off the V. I don't want my command to scroll off the screen. I want you guys to still be able to see the command. And then that's copied it to user local. So then all we got to do is make sure it's on the path, and we can use it. What this is saying is, this is an environment variable, bang path, money path. I want my path to remain that, but I also want to put this stuff in front of it. User local build and export that to make sure that all my programs are able to use that. Okay, now you should be able to say which go. Version, and it should tell you something intelligent. You've got Go installed on your VM. Now, all the Golang developers out there, yeah, I just put it on the path. I didn't put it in the .-rc. I didn't, if you're going to use Go on a regular basis, there is more setup than this than you would need to do. We're just going to use to compile this one program and then forget about it. So if we exit the shell and come back in and this isn't on our path anymore, it's okay. All right. That's it. We've got Go installed. Now, installing Singularity is going to be a pretty similar series of steps. The first thing we're going to do is we're going to download this tarball. You'll notice this is up on GitHub. Oh, this isn't going to work, I bet. Yeah, but I tried this beforehand. It does work. I guess SingularityWare is now being aliased to Sylabs. Okay. Huh, let's try that. All right, in any case, we're going to download this tarball from this particular web address. So it's a GitHub web address. I'll leave it as homework to figure out like where this is coming from if you want. Okay, and then we've downloaded the tarball. The next thing we'll do is extract it. Once again, that fancy tar command. This time we're not giving it a directory option. We're just saying extract it right where we're at. Because we're going to have to compile this. So after we extract it, we're actually going to step into the directory, and then we're going to use the compile. That was the command I just ran. Once again, please follow along on the GitHub repo to make sure that you get lost. Like, show of hands, how many people are still on board? Almost everybody. So I'm probably going too slow. Okay. And if you're not on board, don't worry. We're going to do a break after this. We're going to make sure you're up to speed before we go on further. Okay. Now we've extracted it, but this one's a little bit different. We actually have to compile this. So we're going to be like real software developers now. We're going to compile source code. So the first thing we got to do is we have to CD into Singularity. Now, back up. If you've not compiled source code before, everybody's source code is a little different. So some people use like standard configuration tools like CMake or Make or Auto Tools or something like that. Some people don't. And some people have their own scripts. Singularity switched over to its own configuration system called Make It. But in any case, regardless, there's usually 3 different steps. The first step is to configure the package, the second is to compile it, and the third step is to install it. Some developers kind of take a shortcut and they don't configure, or the configuration and the compilation are both together or whatever, but there's usually 3 different things. You configure, you compile, and then you install. All right, so the first thing we're going to do is configure, and since Singularity now has its own build system, if you cd into the directory and you list its contents, you'll see that there's an executable called mconfig. It's the only executable, and that's the one that we have to run in order to configure this build. So it'll be /mconfig. That's going to go through and it's going to make sure you got everything that you need, all the libraries, all the tools, all the Go environment, all that stuff in order to create Singularity. And it's going to create a make file. That's what a lot of these configuration tools do, is they create make files. This particular one creates the make file in a place called build dir. Have to cd there. Look. Oop. There's our make file. So then the next command should be make. Now we're going to have a little time on our hands because these are easy little virtual machines with only 2 processors, and they're actually doing some work now. They're actually compiling code.
Something people may want to know is how you know the well needs to move. So the files in that top level directory are
Well, so Andy brings up a good point. He says, sure, you know this, and you're telling everybody this, great, but how do they figure it out on their own? And I would not direct people to the files in that directory. Once again, I would direct people to Sylabs Documentation. I think the quick start here has got some installation steps. That's if you know, I hadn't written this documentation and I wasn't here and you needed to try to figure out how to do this on your own, this is where you would go. If you go here, you'll find out too that this is just one of a lot of different ways that you can install Singularity. This is building from source, right? You can also, if you had a Yum-based system like CentOS or Red Hat or something like that, there are files in the Singularity source code to allow you to create an RPM. So an RPM is is something that the Yum package can use to install as it would. So you could manage this installation through Yum through an RPM. Let's see. There are repositories. So we've got there's a repository in EPEL, which I don't even know what EPEL stands for, but EPEL is like the extended rel repository. That's a pretty up-to-speed version of Singularity, so you can just do Yum install if you added that repository, if you added EPEL. You can also do apt install if you add the proper repositories. I don't think that our Debian maintainers are quite as up to speed with the latest versions of Singularity, so you might not get the latest version that way. You can also install Singularity from Vagrant if you use Vagrant. There's some up-to-speed Vagrant boxes up on Vagrant Cloud. There's lots of different ways to install it. Actually, there's a Condon environment. A thief just showed me the other day. Okay, so hopefully that's done compiling now. Our final thing that we need to do is just a make install. So when we did that configuration and we created the make file, it said it was going to install it in a certain place, and in fact, that certain place is going to need root privileges. And in fact, not only that, but Singularity is going to need root privileges when you install it anyway, because it has an SUID file. It has an SUID bit set. That means is that there's a particular executable which elevates privileges on your behalf when you run Singularity. That's necessary because one of the things that you do when you run Singularity is you take this image and you mount it to your file system. That's a privilege operation. Singularity is going to allow you to do that as root. Root's going to do that on your behalf when you run Singularity. Okay. We're going to have, we'll have to debug that if there's a problem. I'm going to take a break pretty soon, and so during the break, one of us will come over and help you. Did anybody else run into errors when they were in make? Okay.
I've got somebody online here that ran a file error.
Okay. Are you guys running the same virtual machine, the Ubuntu 18.04? All right, we'll figure it out during the break. Sure. Very good, yeah.
So what exactly in that little point?
Yeah, so the model, okay, this is, it's kind of changed a little bit since I first started teaching this class. The model used to be, if you're going to use Singularity, you would build your own containers. And so what you would do is you would create a virtual machine, or you would install Linux on an old laptop that you got or something. You would be root in that environment. You would build your containers there. And then after you had your containers built, you would copy them to the HPC environment where you didn't have root privileges, but you could still run your containers. Now that model has changed a little bit. It seems like a lot of users of Singularity are a little bit more kind of consumers rather than producers, in the sense that there's already all these containers that are pre-built up on Docker Hub, up on the container library that we'll talk about a little bit later. So, or, you know, my lab mate has built a container that he wants everybody in the lab to use, so I just grab it and run it. So under those circumstances, you don't need to be root. But a lot of, like, what we're going to be doing in this course is actually, like, I want you to understand how containers work. So we're going to be building, like, I mean, this is hardcore stuff. We're installing Singularity, you know, from scratch. So we're going to be building our own containers. We're going to be doing all that stuff. And to do that, you need to be root. That's changing too, by the way. You don't,
Yeah. Ours is installing. You can still do that on a lot of the software.
yeah, so under those conditions, what you would do is you would install that software into a container, then you would copy that container to HPC, and then you would run it. And that would be fine. You could run that software that you've installed without it. So you don't have to install Singularity on the HPC because that's already installed. That's already there.
No.
Well, I'm going to show you some ways to do it. You don't have root privileges, and the canonical, like old school Singularity way of both containers is you use root. That's changing. There is a way to build them using the remote builder. And what that actually does is it reaches out to a virtual machine up in the cloud. It says, build this container for me. And then it pulls the container back down when it's done. And it all happens kind of transparently. It's pretty slick. So I'll show you how to do that. You can do that on the HPC systems. And as things are, changing, I'm not going to talk a lot about it, but I don't think I'm going to talk at all about it. But sneak peek, there's a new Linux feature called user namespaces. And those have been plagued by a lot of security concerns, and people have been scared of them for a while. But they're going to ship in the next version of Red Hat, and they're going to ship enabled in the next version of 8. So things are changing. Once that happens, you're going to be able to use an option called fake root to build your containers without actually having root privileges.
So when you're telling the story of use Docker environment, so use Docker just to run a container?
So yeah, the question is, do you need Docker? Do you need a root to run Docker on HPC or really anywhere else? The way that you run normally a Docker container is you have to be part of the Docker group. That doesn't make you root, but it does if you know what you're doing. You can escalate your privileges through that group to become root fairly easily. You do what's known as a container breakout. And essentially, if you can figure out any way to write to the underlying file system as root, then you own the system.
Right, but I'm just trying to it seems like Singularity you said you didn't need roots. So it gets around that. With Docker, you would do something special.
Yeah, that's right.
A lot of it has to do with the permissions that are needed, not file system. And they use a different model to get the permissions, not file system.
Real quick, there are just a few more steps to finish up. This next 2 steps is optional, but if you're like me and you're at the terminal, you're always hitting tab to try to, get hints and figure out what the next thing to do is. This is going to install tab completion for Singularity. So I like to do it. The first command is just going to source the correct tab completion file that's already there in your build, that you've already built. Second command is just going to copy that to a system location where it's going to be sourced automatically every time you log into a new shell. So the first command will just work for this shell. The second command will make it so that it works for any shell. Yeah, so if I hit tab twice, I get a list of all the Singularity commands. If I start an option, it gives me all the options. It just makes things a little bit easier. It's optional, but yeah. Okay, and then the final thing that you can do is you can test by running a container. I told you that we're going to be getting a lot of mileage out of this cow. We're going to see this cow a lot. If you see a colorful cow giving you a fortune, some random quote or joke or something like that, then you've got your Singularity installation correct. So what this command did is it ran a container. Now, you don't know what running a container means yet. We'll talk about that a little bit later on. But what it did is it went up to the Singularity Container Services, the library, It downloaded a container that I've created. It ran it, which we'll talk about what that means later, and then it exited Singularity. All right, so let's take a break at this point in time and make sure everybody's on the same page. 10 minutes, 15 minutes, something like that.
Singularity. It basically sends out a small, but it's a modern namespace motions of factors, but it's a matter of having support. That's one of the things that support the open namespace code. So it's doable enough and method enough that we're working on. Yeah, they are. If you look on the sheet, that is the case, but I know that on the map, we're not sure. That's a map one, right? Yeah, Mac. Yeah. And if you want to get serious, all the trouble. Singularity it's portable. It's just the model you want to run on. So for example, if you want to do music with video, you definitely want Singularity. You certainly get a lot of those. This one.
Maybe then it went fine. But then this filter became empty. So.
So, no, this is wonderful. Right. So, beautiful.
We are still getting it out.
Let's. Okay, try this. Yeah. Oh. Okay. I just went up and went back to the directory.
As a close back.
Congratulations.
Yay, without
No problem. Yeah, you will. Right. Just wanted to know on the queue. Anybody else experiencing problems? Yeah, over here.
I'll know how to.
Let me just very quickly send this to What's, oh, I'll pull it up in a second.
And so if somebody's running, then she's on first. Is it possible?
So essentially,
like I want to save, so like I don't. Update. Right?
Okay, so there's room. The Docker. Yeah. I don't have access to the file. Yeah, so it's not too much.
I don't know that.
I think this is you have access. Oh, okay. That's saying that.
I don't have like they don't have money.
So, it's all good work.
But that would be prior. But I guess it's still.
Yeah, this is, we need a root, well, we'll go through. And a lot of this we'll find.
Well, the point is for the right. Setting. Like it's not control or anything like that. It's managed. Right. That's why. Better. That's like. And so, if I'm doing that,
I think so. Yeah, so. Some of the things we talked about. My example here, yeah, so, I mean, really, the using
So you've got lots of
Okay.
hopefully maybe
No, I mean, I just, like, you know, there's that. The different versions. And so,
so what you probably want to yeah, we'll hopefully. How we doing? Is everybody ready to continue? Okay.
Everybody except Cal?
So you might already be sick of that cow. Hopefully you're not, because you're going to be seeing a lot more of them. You definitely will be sick of them by the time, or I guess, by the time the class is finished. The reason, so you know, this is a scientific software kind of thing, right? So you might be wondering, what's with the cow? The reason that I like to introduce containers with this simple little example is that it's kind of trivial. You're going to see these are pretty silly little programs to install. They're very easy to install. But I don't want you to focus on the software which is inside the container. I don't want that to be super complicated. I want you to focus for this class on the container itself. And hopefully the examples that I show you, even with this trivial, silly little example, you can see how they will be applicable to your, your more scientific software, your bigger analyses and so on. Okay. So now we're going to move to Chapter 2 of the GitHub page, or Chapter 1, I guess. Which is basic usage. We should have a working installation of Singularity at this point in time. And so I said that the usage of Singularity is kind of changing. It used to be when I would teach this course before, 2 years ago, it was assumed that you were going to build your own containers. Now it's gotten to the point where it's easy enough to use Docker containers, and there's a big enough community with enough pre-built containers already that there are a lot of users, who just want to use containers. They don't want to build their own. So we're going to go through just like some examples from the user's perspective of how do you use containers, how do you interact with them. That's kind of what we're going to do here. The first thing, if you're going to use containers, you got to know where to get them. So Sylabs has created this thing called the Singularity Container Services, and that is 3 different parts. That's the library, the remote builder, and the key store. The remote builder and the key store we're going to talk about a little bit later. Right now, you should have a look at the library. The library's got a ton of pre-built images. I'm signed into the library right now, so it's going to be highlighting the images that I've built on the library. It's got, the most recent images that were built are all listed here. I think you can just kind of keep on scrolling. You can search for images. So let's say, what's a software that's people like? There's a couple of containers that are named SAM tools that presumably have SAM tools installed. You could download these containers, have a look at them, try to figure out what's going on with them. This is one place that you can get containers. Other place that you can get is Docker Hub. Okay, once again, I'm signed in, so it's going to take me to my page. Here's all the containers I've made. But, you know, you could search for Ubuntu, for instance. Oh, man, Docker Hub is great. Okay. So, and if you go and you look for Ubuntu, you're going to find a bunch of pre-built Ubuntu containers, probably directly by Canonical. You can download, you know, one of those. There are tons of other places too. So these are the two ones we're going to be using for this course, but there are containers everywhere. So there's Singularity Hub. Singularity Hub is kind of like a grassroots, homegrown, early collaboration between Stanford and Singularity LLC, which was Singularity before there was Sylabs. And, you know, that was like the original place that you would build Singularity containers. There's lots of containers there. I think that it's still stuck on the 2X version of Singularity, so it's a little bit older. I don't know how well it's being updated, but it's definitely a place where you can go to find a lot of, like, specifically scientific, and actually probably with a focus on neuroscience type of containers as well. Quay.io, that's Red Hat's Docker Hub. That's Red Hat's like container place. So you can go there and you can find containers. NGC, that is like NVIDIA's solution. So you're going to find a lot of containers there that focus on things like deep learning, GPU usage. Singularity is going to be big with NGC because Singularity allows you to use the GPU pretty easily. Biocontainers is another place, so that's like a spin-off of Condon. There's a lot of containers there, and then I kind of already talked about the cloud providers have their own container repos. I'm not really going to be looking at any of these today. Mostly we're just going to be looking at the Singularity Container Library and Docker Hub. It's good to know that those are there just in case you need them. Okay, in the last section, we started off, the first command that we did was we did a Singularity run, and then we gave it a URI. That URI was library:// Godlove which is my username, funny, which is a collection of containers that I have, and then we ran the container LOL-cow, and that's the thing that gave us the fortune and the funny cow and everything. Let's go ahead and pull that container instead of running it. This pull command is going to allow us to download this container. Give you a little warning here about the container not being trusted. Or maybe it's not trusted. You should verify. We're going to talk about what that means later on. Okay, that's a security aspect. But for right now, just notice that you now have a file. And that file is called lolcow_latest.zip. I'm actually going to repeat that command. I'm going to cd to my home directory. Repeat it. Messed up the source code. It doesn't matter, but in any case, so that file is the container. Okay, that's a little bit different from things like Docker, where you've got, you know, all these tarballs and they're all kind of like in the hidden directory somewhere, and they all have to be stitched together into a container. What can we do with that container? Well, There are, I should let you know too that I've got pretty much the same container on Docker Hub, and you could get that with this command if you wanted to. So instead of using the library URI, you would give it the Docker ://URI, and then Godlove D and then LOLCal. And if you wanted to on Docker Hub, find that container, you could just search for LOLCal. There it is. If you try to download that right now, it's going to try to overwrite the container you've already got. That's going to give you an error. But if you didn't have that there, you could download it that way. Okay, so there are 3 different action commands that we're going to talk about to interact with containers. Those are going to be shell, run, and exec. Maybe not in that order. So the first command is going to be shell. Shell actually lets you pop into your container. Let's do a few things and look at how that works. Before I pop into my container, I'm going to cat, once again, I've already done this, but I'm going to look at the contents of the file etcos release. That's going to tell me I'm running Ubuntu, version 18. The code word is Bionic Beaver. I'm also going to say, who am I? The system, student. If I look at my ID, my UID is 1018. If I look at the name of the host, yours is going to be a little bit different, but it's some variant of Sing class. This is all in the host system, right? Let's pop into our container. Singularity shell, WilCal latest. So our prompt will probably change. It won't always though. So that's going to be determined by your environment, which is different on different operating systems. So don't rely on that prompt to know whether you're not in the container and do something silly like delete your root file system. I can verify that I'm in the container, but because I can, once again, I can dump that file out, etcos release. This says that this container is still Ubuntu, but now we're running 16.04 instead of 18. 2 years older version of Ubuntu that this container was based on. We just swapped out our operating system. Okay, let's run those same commands again. Who am I? You'll notice that you are still the user called student. If you run ID, you'll notice that you still have the same UID of 1018 inside the container. Still knows what host it's on. This is another big difference between Singularity and Docker. So Docker, I wasn't there when Docker was being developed, so I'm guessing, but I'm guessing that what the developers were kind of thinking is, let's make virtual machines, lightweight virtual machines. Let's completely isolate these virtual machines from the host system and from each other. And so that's what they did with Docker. With Singularity, I was there during the development. What we said was, let's blur the lines, actually, between the host system and the container. And let's make it easier for the user to do things like read data from the host system into the container and write data back out to the host system and interact with the kinds of things that they normally would on the host system. And so you're going to see a lot of that. That's why you're the same user inside the container as you are outside with the same UID and everything. We're going to see some more examples of that blurring the lines that they call it. Okay. So for right now, oh yeah, so that's basically the, so we've shelled into the container. The other thing to note is that you now have access to some new programs inside the container didn't have access to on the host system. Fortune, Cowsay, and LOLCat. these are the 3 silly little programs that I installed in order to make this container show that colorful cow. So if I say fortune, random fortune. We'll get something different probably. If I write cow say, give it some text. In this case, I'll give it moo. And it's going to give me some ASCII art of a cow saying moo. If I do fortune and I pipe the output of fortune into cow say, I get a cow giving me a fortune. And if I pipe that cow, oil cat, turns it all pretty colors. That's the entire thing that this container does. Fortune to pipe to cow say to pipe to LOL cat. That's it. So that's what it does when it runs the container. And I'm going to show you later how to write a run script which determines what a container does when you run it. Okay, next let's talk about exec. Exec gives you another kind of quick and dirty way to blur the lines between your host system and the container. Basically what exec does is it executes a command inside the container. It pops into the container, runs a command, pops back out. So let's have a look at that. Oops. First you need to exit the container. Okay, we're back outside on the host system now. Now I'm going to run Singularity exec, name of the container, and then some command to exec. Okay, so I just used the CalSave program, and you should note that CalSave program is only inside the container. So you can only do that inside the container. Do more complicated things, like once again, we return that at etc os release command. It's going to show us that we're running Ubuntu 16 inside the container, even though it's 18 in the host system. So I get there. But first we're going to talk about the third action group called run. So we already did shell and exec. Now we do run in the name of the container. Okay. And what is this actually doing? So when you build a container, there's some metadata that you can assign to your container. One of the things that you can write or assign to your container is something called a run script. That run script lives inside the container, and it is what actually gets executed when you run it. You can see what the run script is for a specific container with the inspect command. Inspect gives you all kinds of metadata. In this case, I want to look at the run script. I'm going to Singularity inspect. I'm going to give it the option run script, and then give it the name of the container. And that's what's actually being run when I run the container. And something else interesting about running the container, so once again, you know, Singularity files are single files. And so that makes them, you can do interesting tricks with them, like make them executable. Notice that this container actually does have the executable bits set on it. Means you can just do something like that. You just run the thing like an executable. That allows you, okay, so now let's stop and think about that for a second. You can determine the behavior of a Singularity container by writing the run script. And then you can just execute the container. So your run script can contain things like options and argument parsing, actually parse the command line and take those options and arguments in the container and do things with them. And they can actually, you can actually have people run the container like an executable, so you could do something like that, and then another option and so on. You can't do that with this container because this one, the run script is not parsing the command line. That is the limit with what you could do with the container. It's very, very powerful. Okay, and then in practice, I don't think that people use pipes and redirection too much with containers. I don't think, maybe they do, but that's because you can do so many powerful things with the run script and so on that I'm going to show you. But you can, so Singularity has been written in such a way that you can use pipes and redirection. They work basically just like you expect they will. Okay. How many of you use, oh, I already got the show of hands. How many of you are using Docker currently? Oh, a few people kind of, sort of. Okay, you guys might be surprised by this. Everybody else is going to be like, whatever. But some people might be surprised by this. All right. So what we're going to do is we're going to Singularity exec, the name of the container, the program calse, we're going to give it new, and then we're going to redirect that to a file called calsed. Happens. But we now have this new file, this new text file called calsed. At the contents of the file out, we can see that the calsed new. Now, okay, everybody's probably just like, okay, you redirected text to a file. Groovy. Calsed program was running inside the container. The file was created on the host system. If you're used to Docker, you're probably like, whoa, what just happened? That's going to be, we're going to get into that a little bit later when we start talking about bind mounting. But this is another way in which Singularity blurs the lines between the host system and the container. It, on your behalf, is going to take your current working directory and also your home directory and map those into the container where you can read and write data from those directories onto the host system. So something like this happens transparently without you having to like bang away and try to figure out some way to do it. Well, yeah, because of the way that I ran this command, I just catted it out to my current working directory, calsed. Yeah, that would create, so if I was in temp, it would create it in temp. If I was, you know, but if I did this, home, calsed, it wouldn't matter where I was, it would end up in home. Do more about pipes. Okay, we can also pipe things into the container. Okay? This might be a little bit more surprising to you guys, this actually. So I just, you know, catted calsed mu, at calsed. I want to pipe that into a Singularity command, name of the image, and then the program. Then I'll give it an option too that says don't do new line. Now I've got a meta cow that talks about cows, or gossiping cows. Yeah, so there's a comment. I didn't get the whole comment, but something about in Docker we
access files on the host system.
Right.
Is there a similar way to access?
Yeah, so the question is, can you bind mount directories the way you would with Docker? We're going to get into that later on, but yes, there is. And the option is bind, and it works with any of the action commands. We'll talk about that more later. So yeah, piping into the container works, piping out of the container works, redirection works, all that stuff works. And I think this is the question that you were getting at before about pipes. Maybe. So this gets a little tricky. This is what doesn't work. So if you just did this without quotes, if you just did singularity exec lolcal.sif fortune pipe calsay.lolcat, let's just do that. It's easier than me trying to explain it. Okay, so remember the run script here is fortune. Anybody have a guess of what's going to happen here? The first command was executed inside the container, but then it tried to pipe that command to a program on the host system, and it tried to pipe that to another program on the host system. Singularity's got no way of understanding when you've got like pipes chained together like this, that should all be executed inside the Singularity container. Get around that, you're going to say, just run the program sh, and just take the command line that I give you. That quoted string is going to be. The actual command which gets executed inside the container is just sh, and also just options or arguments, and Singularity knows what to do with arguments. They exist in the container. So, I don't know. I mean, this is Ubuntu, so it's got bash. I think on Ubuntu, bash is a symlink to dash. So, all right, cool. So now's a good time for questions, and then we're going to get like down and dirty. The question is, what's the difference between the run and exec command? The run command is going to execute the predetermined run script. That's it. The exec command, you can exec anything that's inside the container. Great question. So you ask about the file extension being SIF, and how does that compare with the previous file extension of SIMG? So so file extensions don't matter. This isn't Windows, so we put them up there just to so we all kind of know what we're talking about. This is a SIF file. That is a Singularity image format file. That's what SIF stands for. And that's a particular, only Singularity 3.0 and above will run that. It's got a particular structure. I'm not going to get into that, but it's got multiple partitions. One of them is a file system partition. There's metadata partitions. Before that, we ran just squashfs images with, I think they had a little header. And that was what SIMG usually meant, squashfs image. Before that, if you go all the way back, we used to do ext3. And so it would be like image.ext3. And that's just that's a regular Linux file system. Yeah, it's a good question. There's some nuance there.
It's not a question that's sent directly to
yeah, can you pipe input from one container as input to another container? Sure. Yeah, that works. I could probably do an example of that real quick. But to do that, I mean, you're going to have to invoke the entire command line again. Singularity exec, lolcal. Yeah. That works, but It's clunky. You probably, so I'm, you know, once we get into run scripts, you're probably going to see some better ways to do this. Okay, we got about an hour left. Is that right? Is that what I told everybody? 9 to 12? Okay, good. Now we're going to build this container from scratch. Okay, and so I've waited until you're all tired, and I can attack. None of you will remember any of this. Yeah, so hopefully, like, this is going to be a lot, so you might want to go back over this, you know, try to, you know, absorb this. It might be good to have this rest afterwards. Maybe it won't be that much. I don't know. I'm going to say that, and you guys are going to be like, that was a piece of cake. Okay, so the next exercise, we're gonna build a container. We're gonna do that from scratch, and we're essentially gonna make the same container that I've been showing you, my favorite container that's got the cow inside, which says the funny things with colors. Okay, to do that, we need to use the build command, and we need to have what in Singularity parlance is called a definition file. You'll hear about Docker files. That's the Docker version. Singularity uses definition files. And in doing this, I'm going to pretend that we don't know what container we're building, right? So we know what container we're building. We know it's got fortune, calculator, and LOLcat inside of it. That's all we got to do. We just install those programs, right? But normally, you're not in that situation. Normally, you're like, you went to GitHub, and there's some, you know, crazy scientist who wrote some crazy program that's got 10 million different dependencies, and you're going to like take a crack at it and probably fail, and you're going to try again, until you get all the right versions, all the right dependencies, and that's going to take you some time to develop that. And so the way in which you do that, way in which most people do that, is to create a writable container called a sandbox that you shell into and you play with. And then you try stuff. And when something works, you record that in your definition file. Then you go back, you try something else. And when that works, you record that in your definition file. And you do that for a while until you break your container. And then you take your definition file, you rebuild it from that, and then you start from there. And you try some more things. And you keep on building that definition file out until you've got all the right dependencies, all the right versions, all that stuff. Some people have even referred to that in the documentation as Singularity flow. That's the kind of standard operating procedure for how you develop a new container. So we're going to do that with this container. Okay. What we're going to do is we're going to start with an existing definition file, and we're going to work our way up. So make sure we're in our home directory. And we're going to make a new directory just to keep everything nice and clean. LOLcow. Whatever you want, but then the examples might not work. Get into it. A copy from the Singularity source code, which still lives in our directory because we never cleaned it up. There's a subdirectory called examples. That's got all these different example definition files that are just like there to try to get you pointed in the right direction. I'm going to make things a little bit different. We're going to use Debian instead of Ubuntu, just for a change of pace. And that definition file is actually called Singularity because we name everything Singularity. I'm going to rename it to lolcow.def, which you know it's a definition. Okay, so if that worked, you've now got lolcow.def in your current working directory. Once again, if you get lost during this, please refer back to the script. Hopefully I'm not deviating from that, and you can just copy. Yeah, that was this series of commands. Let's actually look at this. You're going to see me type Vim, lolcow. I encourage you to use nano if you're not familiar already with Vim, okay? If you're familiar with Vim, go for it. But Vim is going to be, it's going to be hard for you to use, and it's going to be hard for you to exit. So just nano, unless you. Okay, this is what the definition file looks like. It's got multiple different parts. The first part here is usually referred to as the header. Then we have a run script section and a post section. Go through all this. The header tells you what container do I want to start with? How do I build this? How do I build the starting container? Okay. Remember at the very beginning of class, I told you that one of the programs we were going to be installing was DE Bootstrap. The purpose of DE Bootstrap was to build a Debian-like file system. That's what we're going to be using here to build this container. We're using DE Bootstrap. This Bootstrap field, there's maybe like 6 or 7 different Bootstrap methods you can use. You should refer to the documentation to learn all about them. They will determine then what keywords make sense to use underneath. With the DE Bootstrap keyword, you've got an OS version that you can enter. In this case, I'm going to use stable. And then you've got a mirror URL. Let's go there. Maybe this will make a little bit more sense. So this is probably confusing, okay? And that's okay. This should be, maybe confusing. What is this place? This is one of the Debian mirrors. So if you're running Debian and you run apt-get update, this is one of the places where Debian might go to check for updates to all the programs. Or if you run apt install git, it's going to go here to grab git and install it on your system. This is one of the mirrors. If we go into dists here, that's all the different distributions. Debian uses Toy Story characters as code words on their distributions, just to be super confusing. That's why you see like Buster and Bullseye, Stretch, there's all kinds of different ones. But we're interested in stable. That's the actual distribution that we're going to be downloading and building a file system out of. Okay? And so that's what this is saying. It's saying we're going to use this program called DE Bootstrap. DE Bootstrap takes something like URL. That's the URL we're going to give it. And we want the stable version of the operating system. And you got to read the documentation to understand how to use these different ones. Luckily, later on in the course, we're going to talk about how to build from Docker Hub or from the library. And that's a little bit easier. But here I want to show you, this is actually going to build an operating system from scratch, from the mirror URL. Okay, the next thing we see here is the run script. We've already talked about that a little bit. So this keyword here with the % sign and then run script, it says, this is what I want the run script to be inside of the container. And this is a really simple one. It's just going to use the echo command, and it's just going to say, this is what happens when you run the container. It's not going to do anything useful, but that's all it's going to be. And then post is everything that happens inside the container after you build the base of the container. So in the header up here, you build this base container, and then you step inside of it, and you execute everything in post. In this case, we're just going to echo and say, hey, we're inside the container, and then we're going to say apt-get, and we're going to install Vim without any authentication. I don't know why this is saved as an example, but in any case, let's build that. Let's build this container. You did go into Vim, hit escape. Your prompt will be down here. Thank you, and you can quit. Otherwise, if you went into nano, like Control X, I do Singularity, build, to add a little a little option here, sandbox. And I'm going to do this as root. Before I hit enter, I'm going to go through this command a little bit better. All right. Using Singularity build, that takes two arguments, the name of the container and the definition file. Notice I don't put .diff because this sandbox option is going to build their directory. That sandbox is something I can pop into and mess around with. I'm doing all that as root. Because you got to be root to build, to use things like apt inside the container, which is what we're using. That's going to take a few minutes. I think there's going to be some problems with its ability to actually authenticate, have a key that it wants. Now's a good time to ask questions if you got them.
From the web when you're ready.
Ready?
Okay, so the first one is, what's the difference between Docker running Docker exec as compared to Singularity?
I'm ashamed to say I don't know Docker well enough to do that question justice. I assume they're pretty similar, but I don't know that for sure.
And so the second thing that I'm presuming you're getting later tomorrow is, can we do GUIs with this?
Oh yeah. Yes. The question is, can you install a GUI inside the container? I'm not actually gonna go through that.
Okay.
The reason I don't go through that is because everybody here's got a different SSH client, and half of you guys probably it doesn't support X. Probably 3/4 of you guys doesn't support X. So if you tried to follow along, it wouldn't work for various reasons. But yeah, if you have a client that supports X11, that's one transport for graphics, or another one or whatever. Yeah, you can install Xorg inside your container, and then you can do things like, one of the wacky things I've done with containers is I've installed Wine, which is a Windows emulation program to run Windows programs on top of Linux inside the container, and then installed a text editor, Notepad++, which is GUI based, on top of that. And, that runs pretty much without a hitch. And then you've got Notepad++ running on Linux, which is pretty fun. Okay. Any more questions before we look at our container? All right, let's look at it. So now we've got this directory. Actually, if you look at the contents of the directory, you're going to see it looks an awful lot like a root file system. Right? It's a root file system. It's got some symlinks that you might not expect in a root file system. This is where the Singularity metadata lives. But other than that, it's just a root file system. Okay, so now, let's refer back to the course material here. We've built the container. So now let's pretend that we don't know what's going to go in the container. We have to start developing this container. So we're just going to go ahead and shell into the container and start noodling around with it. And usually, one of the first things you want to do is do an apt-get update. Singularity shell. Oh, yeah, thank you. That would work just fine, but. Oh, wait, no, I actually should be there. This is, no, don't go in here. This is confusing because it's home, LOL count, LOL count. Right? So maybe I should have named that something different. You could go in there, it wouldn't, but then you would be building containers inside of your container, and that might not be good. All right, so Singularity shell LOL count. We're about LC all. Okay, but in any case, yeah. So in any case, now we're inside the container. If we run apt-get update, we're going to run into a problem. And that's because we tried to run apt-get update and we weren't the root user. This is one of the reasons. And you're going to find that even if you install sudo inside or if you set a password for the root user, or if you wrote a tricky little program to escalate your privileges, none of that stuff would work. And that's kind of the key to Singularity, right, is that if you're not root on the system, you're not going to be root inside the container. We won't let you be root inside the container. So we have to enter this container as root. I'm going to give you a hint too. When you enter the container, you also need to give it this option, writable, or else it's going to mount the container as read-only, and you're not going to be able to make any changes to it. So if we want to get into this container, noodle around with it, and try to figure out how to install our software, we need to shell into it as writable. Now if we run apt-get update, we shouldn't have any problems. So normally that LOLCal directory would be mounted as read-only. And so if you tried to do apt-get update, it would say, is a file system, can't do it. Now it's mounted as read-write, and in fact, these changes will persist. Shell out of this container and then shell back in. That update will continue to persist.
You stay behind.
Oh, sorry, folks. I gotta stay here, evidently. Okay. So we did apt-get update. Now we're going to go ahead and install our programs. I'm going to go ahead and when I do install, I'm going to give it this -y option. And that's going to say, I want to do this. Don't ask me yes or no. I already know I want to do that. That's going to be important when you create your definition file. The definition files have to be run non-interactively. So they can't stop and ask you for a prompt or whatever. They'll die. Okay. That should be good to go. And so now if I do something like fortune, the reason it's going to give me an error, once again, you wouldn't know this. You would be confused at this point. You would have to try to figure out where the heck fortune went. But I'm going to tell you, I don't want to spend a whole lot of time. Fortune got installed in user games. User games, by default, is not on your path in Ubuntu. And so you've got to export your path variable. So once again, this is the development stage. Normally you'd be like, crap, where the heck's fortune? And you might do something like cd / and find -name fortune, where did it go? And then search the directories and but I've already done that, so you don't have to worry about it. So we need to do export path equals now, if you've exported that path variable properly, you should have fortune. These other ones, because they're in the same directory. Okay, that worked. This is ugly. So we got some problems with our locale. Perl is complaining about its locale. Silly Perl. This is a common thing that you get a lot with containers, and the easiest, quickest thing to do is usually just like the LCL variable to see. That's what I'm going to suggest that you do. That's what I'm going to do here. And once again, this is something, if you were developing a new container and you hadn't encountered this problem before, you'd have to go Google it and, maybe go to the Singularity Google group and ask the question or get on the Slack or something like that. So you already know. This is a really common thing that you see. This is just going to tell Perl, don't care about different locales, just set it to a default locale and just be done with it. Yeah, that's a little curious. I didn't get that error either when I was developing this class, so I don't know why I'm getting it. But sometimes you get it if you do. And I think I've got a note in the. Okay, so now if I run this again, should be good to go. Now, once again, normally, if you were doing Singularity Flow, you would be recording in your definition file. This worked, this didn't. Here's a command to run in post. Here's a command. I'm not going to record whatever. This is a short enough exercise that I pretty much can remember everything that we did, and I'm just going to go ahead and record that in my definition file. So. Once again, this gets back to, so this is like, right now, this container is just a bare directory. It's just a sandbox. And all the changes that we've made in this directory are not recorded anymore. So one of the things that a container normally has recorded in it is the definition file. You can get that back out of the container and see how it was built. This definition file is not going to contain these commands for installing these programs. Another thing is, it's just a bare directory. So if I want to copy it from one place to another, I'm going to have to tar it up, make a tarball out of it. It's not going to work well with the Singularity Container Services, the library that we're going to talk about later. So we really want this to be a CIF file. So we want to rebuild it. So let's write all this stuff into our definition file for the record, rebuild it, and then we're going to have an immutable compressed container that's good to go in that production environment. Exit your container, use nano or vim to get into your definition file. Header's good. Our post section needs some help. So first off, I don't care about during build it telling me that it's inside the container. I don't really care about it installing Vim. I don't care about this unauthenticated option. We didn't use that, and it worked just fine. So we'll do apt-get install -y, or -y install does the same thing. And the programs we installed were Fortune, I'll say, LOLcat, and, okay. Yeah, post, it means after you build the base. Yeah, so it builds the base, and then Singularity pops into the container and executes everything in post.
If you go into the documentation, there are other options that will install other things as well that are part of the run script. And this is my analogy. If you've ever made an RPM,
just as an aside, so you brought up an interesting point. The definition file might seem a little clunky, like where did the syntax come from? And the reason it looks the way it does is because it copies a lot from RPM. And the reason it copies a lot from RPM is Greg is like a huge RPM advocate. He loves RPM. He's read the book Maximum RPM, which is like the guide, like cover to cover, and knows it really well. And in fact, CentOS, so back in the day, he started a new distribution of Linux called Chaos Linux. And he started the Chaos Organization, or the Chaos, I don't know, I think the Chaos Organization, which, Chaos Foundation, which was the foundation that ran Chaos Linux, and that ended up becoming CentOS. And what they were trying to do is at the time, there was no good community-driven RPM-based operating system. They were trying to create a community-driven RPM operating system, which became CentOS. So he loves RPM, so that's why the definition file looks like this. I'm going to add a new section. Once again, you need to refer to the documentation, Singularity Documentation. There's lots of different sections, as Andy mentioned, that you would use under different circumstances. There's one called %sign files, which will copy files from your host system into your container at build time. That's useful. There's some other ones, too, that I'm not going to really get into. There's a test one. There's lots of stuff. But we need environment because, remember, we set our path. And I, for whatever squirrely reason, ran into this locale. Need to fix that too. You may or may not actually have to set that environment variable. It won't hurt anything. I'll leave that up there for a few seconds. You can make sure that your definition file looks the same. The question is, what if you want to install software that's not in the package manager? It's a great question. So, yeah, so this post section, it can have anything in it. It can have wget commands. So say you want to Go inside your container. We installed Go as one of the first things that we did. The way we did that was really easy. Go has pre-compiled binaries packed into a tarball archive that you don't have to compile. You just extract them to a certain place. And so what we would do if we want to go in here is in the post section, we would have wget, the URL to the Go tarball. We would have then the tar command to extract it. And then we would be extracting that to user local. We would set it on the path. And if we did that, we would run into a problem. And the problem we would run into is that the container would say, I don't know what wget is. And we would have to apt-get install wget. Yeah, this is just straight up shell. And all the different sections pretty much in the definition file are just straight up shell. So whatever you can do with a shell script, you can do in here. There's a but there. And the but is, it's shell, it's not bash. And your container is not guaranteed to have bash in it. So you got to stick to, so there's this whole standard called POSIX. And POSIX is a bunch of people got together and they said, we want all these shells to act the same. And so it's a subset of the commands which are available in bash. You should use POSIX because if you start from like an Alpine container, for instance, it's not going to have bash in it and it's not going to do bash isms. Sure, yeah. Oh, no. Nope, you can, this is not Python, that works. Yeah, I just do that just because it's easy to read, but yeah, it's bash, it's not, or it's shell, it's not like that anyway. Okay, so let's build it. Hopefully everybody's got the same definition file. So Singularity build locale sif Notice we're doing a CIF file now, and we no longer have that ready. This is going to take a few minutes as it tries to.
There was a question. Oh, here we are. Can we modify containers by installing new packages when we need instead of rebuilding it?
That's a good question. Yes and no. You can build a container from a local image on disk. So you could say I want Vim inside this container. I could just build in my header of my definition file, the bootstrap method would be local image, and then I would give it from path. And the path would be like /home/user/container, and in post I would install Vim. That's going to give you a new container. I'm going to show you in a minute, you can convert an existing CIF file into a sandbox and then shell into it and play with it. And then you convert that back into a CIF file, but that's really dirty and gross because then you've got this file that's got no history, you don't know how it got that way. There's a new method of something called multi-stage builds. And what you can do there is you can build multiple containers with the same definition file. The first container can include something like a development environment that has compilers and language environments like Golang and stuff like that inside of it. You can build whatever it is that you want, and then you can copy that compiled executable into the next container that you build. You do all that in the same definition file. So, yes and no.
You can't just flat out edit something that's in a CIF.
Yeah, so if I just popped open the definition file and just added another command to post and I reran it, it's going to rebuild the whole thing. Mm-hmm. It's not going to be smart enough to say, oh, I've already got all this. And that's the difference with Docker. And the reason that we can't do that with Singularity is because Docker utilizes layers to be able to figure that out. We don't have layers. It's a totally foreign concept. Okay, so we now have our CIF file. Run it. Oops. It just says this is what happens when you run the container. Just remember that's our definition file. Okay, we're almost done. I'm just going to go through. So that was, maybe I should stop for questions because that was probably the hardest thing, the most complicated thing that we're going to do in this session. And then I'm just going to show you a bunch of little tricks, a bunch of little, like building from existing containers, building from URIs, converting containers from one format to another, and stuff like that. So do we have any questions before we get into that? Nope. Okay. So you guys, are you just wasted and just mentally drained at this point, or no? Good. Okay. Excellent. You guys are smart. All right. Yeah, a lot of times people at this point in class are just like, okay, so we can. Yeah, so in this case, what it's doing is it's used, so if you're outside of the container, you say which bootstrap, you'll see that there's a program that's saved on the host system called bootstrap. This definition file is using that program, and that program predates Singularity, and it was written to go up to a URL that you supply and to grab the necessary components to build a root file system. Greg just said, it's cool if that's already there, I'm going to use it. Now, if you're going to build from CentOS or something like that, Yum can do the same thing. Yum can build its own root CentOS file system. It's got some quirks that make it a little harder to use, but it can do the same thing. I think if you're going to use let me think for a second. Is it Alpine? Uses Packstrap because its package manager is Pacman, so I think it uses Packstrap to bootstrap and do. So there's lots of different ones like that. I'm going to show you a more generic one though, and this is the one people normally use. I showed you like basic principles so you guys will understand from the ground up how everything's going to work. Here's what people usually actually do. They do or, so this is going to build from the container library, which is hosted by Sylabs, or Docker Hub, just get Debian. Now you probably wouldn't want to do this if you wanted your container to be reproducible, because what Debian is that? Well, Debian is going to be updated all the time. It's going to change. It's going to be different. So what you would probably want to do is use a tag. I've not talked about tags yet. We're going to talk tomorrow a little bit more about Docker Hub and a little bit more about the Singularity Container Library and like things, you know, that have to do with that. But one of the concepts there is tags. So there's a Debian 9 tag. And that's going to be a little bit more reproducible, but somebody still might swap that tag out. So I'm going to talk tomorrow about building from actual SHA-SUM, which is going to be, you know, more reproducible. But in any case, this is what people normally do. People usually don't build from mirrors. And you're going to find that this is a lot faster too, because all you're doing is you're downloading a pre-built container as is and then popping into it and then doing stuff to it. Let's go ahead and rebuild that just for fun. It's going to say you overwrite your container. I sure do. Oops. That might, okay, so once again, if we were developing this container, because that's a flub, probably does not contain the universe repositories or whatever repositories it needs to get those. I might just have to update it.
Yeah, when you're building against the
Yeah, this goes back to one of your original questions, I think. So let's try this. I think this will probably work. It's just not configured right. Oh, whoops, I do have those programs. I just didn't know where they were.
The images that you get from Docker library or Debian and the like are what's called bootstrap images. They are literally anyone you need to start installing other packages. So you probably do want to have to get and make sure you have a full library to start following on other.
So this is building from the library, from the container library, and then going inside the container and doing, you know, the post section. I'm not going to build it, but if you wanted to, also do something. And okay. That's going to start with that container that we just built. It's going to start with that as a base, and then it's going to go in there and execute post. In this case, this post doesn't make any sense because it already installs all that stuff, but you can put different things. Now, I'm going to show you some shortcuts too. Yeah, maybe it's instructive for me to actually do that. So in this case, I hope I don't need this for anything else, but I'm going to blow this away. I could do something like now the container that I built from this is going to have fortune, LOL cow, or calsay, lolcat, and now also wget vim installed. This,
Kind of being standard. I'm sure I won't install it.
yeah, you could use this as a method to save yourself time during development. It's probably not a very good practice because I think that this is, it used to be in the Singularity 2x version of Singularity, it would save every definition file that had been used to create that final image, and it would stack them all up, and you could actually go back and look at them and figure it out. I don't think it does that anymore. I think it just saves the latest definition file, so this would be untraceable at this point. Now, you don't just have to build from a definition file. You can also build directly from URIs. So you could do something like this. I'm going to start calling, I guess, images. I guess I'll stick with the script so you can copy and paste it. So you could do things like Singularity build, Debian1.sif, library. Debian. Now I'm not building from a definition file. I'm just building directly from, and this is pretty much the same as just pulling an image. In fact, under the hood, functionally, I think this is like, I don't know why you would want to do this. Might be reasons you want to do this, I don't know. It's pretty much the same as pull. So you could use this as a, it might handle metadata differently. I don't think it does though. I think it's just the same as a pull. You could also build directly from the same way. Now, this is kind of funny because that is the same as a pull. Really, it's more like a pull. It's just downloading it. Not building it. You can do Singularity pull from Docker. That's not really a pull. That's a build, right? Because you're taking these layers and you're creating a zip file. Actually taking some data and building. But you can actually write Singularity pull Debian, and it does the same thing. Under the hood, they're synonyms for each other. They do the same thing. But they're kind of different. And then you can also do Singularity build Debian 3. I'm just going to do that from Debian 2 container. I have to give it the full, oh, it's a zip. Now, in each of these cases, what Singularity does for you on your behalf is it creates a definition file, and then it feeds that definition file to itself to create these things. Those definition files by using the inspect. If I do Singularity inspect, remember previously we used inspect to look at the run script. Now we're going to use inspect to look at the definition file. Okay, and we can do Debian1. That was the definition file that it created. 2, same definition file but from Docker. 3, local image, Debian2.sif. The third example here you might think is ridiculous, and it is kind of ridiculous because all I'm doing is I'm copying a file. I can copy a file a lot quicker than doing it this way. But you can also use that to convert a file from one format to another, and this can become useful if you download some container from the wild. You want to know what's inside of it. You can convert it to a sandbox, and you can shell into it, and you can look, or not even shell, you can just CD into it as a sandbox, and you can look around and see what files are there. Let me show you how that works. So instead of building Debian 3.sif, I'm going to build Debian 4. I might fill up my disk here. I'm going to build that as a sandbox. Build that from Debian 3.sif. And this is just a fancy way to convert your containers from one image format to another, quick and easy on the fly. I could make that writable. I could go in there and start noodling around with it, developing it. Yeah, when you're building from URIs or building from local images, stuff like that, it's not necessary to use sudo. And that's because what you're doing is you're downloading and creating SIF files. I'm supposed to stay over here. You're not using apt or anything like that to actually change. Okay. Okay, one more thing. I'm going to touch on it. All the way, so we're going to talk about security now a little bit. I forget, somebody asked about security before. Now we're going to start getting into it. Who was it? Somebody?
One of our
Okay. So throughout this class, I've been telling you to run Singularity or sudo Singularity build, yada, yada, yada. Okay? Another thing you can do is like sudo Singularity run something, something, something. If you do sudo Singularity run some container, basically what you're doing is you're downloading somebody else's code from the internet and you're running it as root. And that's a bad idea, right? You wouldn't just download some shell script that you found off the internet, not read it, and then run it as root. It might do something like delete your file system, right? Or it could do more insidious things like take your VM and start using it to mine Bitcoin or to, you know, share files or, yeah, bad stuff. So that's clear with Singularity run, right? Actually, the same thing can happen with Singularity build. So if I have something as innocuous in my post section as an echo command, seems totally fine. I build from some image, I just echo something, seems like nothing can go wrong, right? Wrong, because echo relies on the glibc libraries, which could have been rewritten by whoever created that container to do whatever they wanted to do. And so that's bad. So normally, even though I've been showing you, for ease of use in this class, sudo Singularity build, and these are virtual machines, so even if they get owned or whatever, we can just delete them afterward. But normally you don't want to do that, and you especially don't want to do that on a system you care about. Okay? What you can do instead, yeah, okay, I'm okay. What you can do instead is you can do Singularity build fake root. And then you can, do that from a definition file. I don't even know what state our definition file is in now. But what that's going to do, so the reason that's going to work is because didn't work. Oh, you know what? I found that this does not work with 18 for some reason. So this is still buggy. Okay. I found for whatever reason, I'm going to have to raise an issue on this. This doesn't work with Debian. Let me, you know what, it might have already been built as root, and so it's got real root-owned files in it.
Yeah.
So what this does is it maps your UID outside of a user namespace, UID 0, the root UID, inside of a user namespace. It allows you to be root. I might not have enough space.
What do you do to a -1?
Oh, thank you. So in any case, what this is doing is allowing you to be fake root inside of a new namespace. And this is a much safer option. Now, obviously, it's also a little clunkier. Okay, now I think that error was, as Andy pointed out. But I've also run into some problems where there are certain containers it doesn't work well with. You can't mix like a container that has been built as root, real root, with this command and so on. So I'm going to show you tomorrow another thing that you can do. You can use that -- remote option and just build on the cloud. And that way, you know, if something bad happens, it's going to happen on some VM that you don't care about, up on, you know, some cloud that you don't care about. And then, you know, your container back is going to be pretty good to go. So that's a security consideration. And we're going to talk a little bit more about some security considerations tomorrow. All right, we got like 10 minutes. I guess we could ask questions or just wrap up early if everybody's tired.
I ran out of batteries, so if people who have questions would send them along. Okay, I answered that one. We're good.
Okay. Yeah, does anybody online have any questions while I'm looking here? I couldn't hear you, I'm sorry. Yeah, those login, yeah, keep the same VMs. Those same VMs are going to work for you tomorrow. They are not going to be fresh VMs. They're going to be your same VMs. So whatever you've got on there now, you're going to have tomorrow.
You've got one.
Oh. Yeah, so I didn't really talk about the cache. I don't know if you can read that, but the question is about the cache. Yeah, that'd be a good thing to talk about. So let's see. If we CD back home and we look at everything with LL all, you're going to see a .singularity directory in your home directory, and that is your that gives you some metadata, and it also gives you a cache. When you download containers from the internet, the second time you download them, they come a lot quicker, and that's because they just come out of this cache. The question is, should we clear the cache from the package manager? Oh, no, the question is about clearing the cache from the package manager. I didn't catch that. Okay, while I'm talking about this, I'll finish this thought. So this cache can get clogged up with lots of, you know, images and things like that, and so you can clean it from within Singularity with the cache groups of commands. So you can list. There's 2 container files. This is how much space they're using. Might be able to custom get exactly what those things are, and then you can clean them. The only catch here is that a lot of the containers that we built as root. Root's got its own cache in /root, so we would have to be root to clean those containers. Sudo I, and we became root. Also, Singularity metadata, and that cache would also need to be cleaned. Sorry, the question was about the package manager. Yeah, so you would normally want to do something like apt clean afterwards. There's actually a list of, there's a lot of different commands, few different commands that you could use, which are going to do things like clean out the cache inside the container, and that's just going to make your container a little bit smaller. And so it's a best practice to do that when you're building. More questions?
Being able to clean your Singularity cache when you're on viable is important because you only get 16 gigs for your home directory. So if you're doing a lot of work with downloaded images, you may in fact run out of space. So keep these in the back of your mind when you're running on the cluster.
Okay, well, that's all I've got. If you guys have any more questions you want to ask me afterwards, feel free. Otherwise, I'll see you tomorrow.
Lots of stuff.
Yeah.
Programs. Yeah.
Okay, I'm going to kill off the virtual machines.
Good idea.
Stop them.
Actually, we can give it a. Let me check.